This is question 2 from the reserve paper from 2022 of A2 Pure Maths from CCEA. Let's take a wee look. The shaded region R, as shown in figure 1, is the major segment of a circle. So that's this bit here of radius R with angle AOB is pi over 3. So the fact that that's pi over 3, we know then that's the same then as 60 degrees. So that might kind of help us in some of the workings in terms of what we have to do. So find the perimeter of R in terms of R. So we got to find this distance here and then find this distance here. Well, the first thing I would note is because that's 60 degrees and those are both the same length, then that's 60 and that's 60. So this is actually a wee equilateral triangle. So if that's R and that's R, then that wee distance, a straight distance along there, needs to be R. So that's going to help us. So our perimeter, let's see, is going to be, so the perimeter then of a circle is obviously the circumference of a circle. So it's going to be 2 pi R. And then we need to kind of take away this wee dotted line. So that's just going to be R theta. Remember, our arc length is equal to R theta. So as in this distance here is the radius times the angle. So it's just R upon pi over 3. So what have I done here? I found the circumference of the circle and I've taken away the dotted line. And then we need to add on the last wee bit then, which is the R. If we tidy all that up, we kind of have, let me see, 2 pi R minus R pi over 3. So that gives me 5 pi R over 3 plus R. On to part 2, the perimeter of R is 10 pi plus 6. Find the value of R. So we're just going to use what we worked out then previously. So we know 10 pi plus 6 equals 5 pi R over 3 plus R. If we're trying to work out what R is, it's probably easier to kind of factorize the R out here. So I'm going to rewrite this in as 10 pi plus 6 equals R upon 5 pi over 3 plus 1. And so R then is going to be 10 pi plus 6 all over 5 pi over 3 plus 1. And again, you can kind of put that into your calculator or whatever way you want to do it. You can kind of tidy it up. You times top and bottom by 3 and things do kind of factorize out. But the answer here is simply 6. Final thing they want to do then is find the area of R. And again, a couple of different ways of doing it. We could find the area of the whole circle and take away that wee segment. I think I'm tempted to find the area of this major sector and find the area of this triangle or something like that and work from there. So first of all, the area of the triangle, it's a half AB sine C. So first of all, my triangle, so it's a half times 6 times 6 times sine pi over 3. Sine of pi over 3 is root 3 over 2. And so whenever you kind of tidy this up, this is obviously 36, that's 18, and then kind of root 3 over 2, you end up with 9 root 3. So that's the area then of the triangle. The area then of the minor sector is going to be a half R squared theta. So that's going to be a half upon 36 upon pi over 3. So a half of 36 is 18 divided by 3 is 6. So that then just gives me 6 pi. So what have I just worked out there? I've worked out effectively the area of this wee bit here, the dotted line. It's like the wee kind of slice of pizza. We're going to find the area of the circle, take away that slice of pizza, and then add on the triangle. I hope that makes sense. Area then of minor segment, we're actually going a slightly different way, then is going to be 6 pi minus 9 root 3. So what have I done here? I know the area of that slice of pizza, I know the area of the triangle, and I'm taking them away to get that. I'm now just going to work out the area of the circle and take away then the area of the segment. That's pi r squared, so that's going to be 36 pi. And then my required area then is going to be 36 pi, take away 6 pi minus 9 root 3. The 36 pi take away the 6 pi gives me 30 pi plus 9 root 3. And my area then is in centimetres squared.